think we can start. So today is gonna be the last course of the workshop series. Just to inform you, it's a small and short course. Actually, it was supposed to be done with the previous one. Didn't want to overload with a lot of information, so we created this one. We're gonna start with some data visualization, see some examples, and then we're gonna move to the most important part for me. Like, I really, you need to, like, it's a must nowadays. Docker. You should learn it. Not only for artificial intelligence and the data science fields. It's gonna help you a lot. You're gonna see this. So we're gonna start with small data visualization examples, and we're gonna move to Docker. But before that, we're gonna practice a little bit with Docker. So if you can start by going here, Docker desktop, and install it, because we're gonna do some examples on it and some exercises. So go here, Docker desktop. Either you are Mac user or Windows, it's gonna be the same. And download the last version here, either for Windows, Linux, or Mac, and install it. All right? Just select this. Okay, so hello again. Just in case there are a new participant, my name is Abdelghafour HALIMI. I have PhD in image processing and artificial intelligence from the National Political Institute of Toulouse in France. And I was working as data scientist for worldwide companies, and I have over a decade of experience in the AI field, working for several projects in different fields. And I recently joined the Visualization Core Lab. So Core Lab provides a lot of facilities and expertise for various fields, like 3D data visualization, virtual reality, and finally data science. So don't hesitate to contact us. I'll put you some links here for our wiki page. You can check also our YouTube channel, where you can find the previous tutorials and training provided by me and my colleagues. Okay, so what is data visualization? Data visualization is a general term that describes any effort to help people understand the significance of the data by placing it in visual context. Now, why is it important? Because it's going to allows you to simplify complex data, reveals patterns, correlation, and trends, and it's going to be allowing you to enhance data storytelling, which is very important, especially if you are working for companies. Now, there are some challenges. You want to avoid overloading with information and misrepresentation of the data. Now, where are you going to use it? It depends on the problem that you are working on. But imagine you are working for the machine learning projects. You remember, we have seen this. Machine learning comes in three main parts: data collection, data modeling, and deployment. You're going to find it in the data modeling and deployment part. In the data modeling, to do some exploratory data analysis, some EDA, or in the deployment, where you're going to create a dashboard or an application, and you're going to share it with your colleagues. Now here, this is a small map to how you're going to choose your chart, depending on the problem that you are working on. For example, if you want to do some comparison among item or over time, relationship, composition, or distribution. This is an old one, still working, still do the job, but you can always go here in chart guide, and you're going to find this new one, which is more sophisticated, of course. And it's going to help you how to choose your chart when you are working on some problems. Now, these are the most useful Python libraries. Again, it's specific to the data science fields. So, yeah. Yeah? Which one? Okay, this one?
I mean, how do you choose this one?
Sorry?
How do you choose? I mean, it depends on the data.
Yeah, depending on the problem that you are working on. For example, here, it's a simple example. If you are working for, and you want to choose something to compare among item or over time, it's going to give you the idea which one you're going to need, like circular data, or maybe bar chart, or category. It's going to give you which kind of type of derivation you wanna use.
Here it is clear because you have four.
Yeah, but yeah, exactly. But here, the same thing. You can find categories, time, part of the whole distribution, geospatial relationships. It's gonna be the same thing. Just go here, chart.guide, and download this poster, and you're gonna find all of the instructions. All right. So these are the most important libraries: Matplotlib, Seaborn, Folium, Plotly, and finally Streamlit. Let's dive into it. So we're gonna start with Matplotlib. It's built as an alternative of MATLAB, of course. So it's plotting library for Python programming language, and it provides an object-oriented API for embedding plots into applications. The purpose is to visualize, of course, data and understand the patterns, trends, and insight. And it's gonna also help you to make decision making and storytelling. Now, some key features. You can create various types of plots using this Matplotlib library, like bar chart, histograms, scatters, plots. It's a very vast one. It's very customizable. It's important for Matplotlib. And one of advanced features, you can create 3D plotting and 3D visualization using it. Now, for Seaborn, it's gonna be same thing, but it's Python library based on Matplotlib. It's a high-level interface for drawing attractive and informative statistical graphics. The purpose is to visualize this time complex data set to uncover underlying patterns and insight. It's very used for statistical analysis because it has already built-in regression models, like this one you can see here. It supports the fitting and visualizing linear regression. It's easy to use, and it has a lot of stylish themes. Now, next one is Folium. Folium, it's a library for creating interactive and dynamic maps, built on the top of the most known one, which is the leaflet on JavaScript library. And the purpose is to visualize data manipulated in Python on interactive leaflet maps. It's very used when you are working with geospatial data. Now, some key features. You can create interactive maps with markers, pop-ups, and other features. It's easy to be integrated. It's easy to use and integrate it on Jupyter notebooks, which is amazing. You can present it with the Jupyter notebook. Wide range of customization options, including map styles, tileset, and overlays. And finally, here, we're gonna move to the Plotly. Plotly is taking this a step further by creating each of the different visualizations that you have seen, but this time in an interactive way. So it's gonna help you to create a wide range of static and interactive visualization. And it's very useful when you are create some dashboards later. You're gonna use this kind of library, Plotly. So again, it's create plots to allow you to not only zoom, hover, interact with the data. It's versatile, and you have a lot of customization on it. Buttons, sliders, and drop-down to control the visualization. And it's adapted to be used for dashboards in order when you're gonna create some application and share it with your colleagues. And finally, Streamlit, which is a new library, very used in the data science field nowadays. It's a fast and easy way to create data app using Python. So if you wanna create machine learning app, you're gonna use this kind of library. It's very rapid to prototype and deploy it. And it can be used either to create some EDA, exploratory data analysis, or machine learning application. This is the use cases here. You can see it here. Machine learning showcase or data exploration. Okay, so this is a small comparative overview of the different libraries. You can see that Matplotlib is a basic plotting, very used for academic and research publication, a lot. Seaborn gonna be the same thing, but this time for statistical analysis. Folium, when you are working with geospatial analysis or geospatial data. For example, if you wanna do some monitoring on or forecasting of dioxide carbon. Plotly is very used to when you wanna create dashboards, because it's already interactive. And Streamlit is to prototype these dashboards and application. some helpful tips. Want to avoid always the angles when you are working with comparison. For example, what's your favorite animal? Don't use a pie chart. It's very difficult for a human to be understand here. It's very difficult. Choose a bar chart instead, of course. And here you can see that directly you see that the dogs is the most favorite one. Avoid also the area when you are working with ranking, for example. It's very hard to see that C is the most, that the one has the most area. Use bar chart. Okay, now let's try to go through this and get an overview of all this. Yeah. No, not all. No. It depends. It depends if you want to show some. Yeah, exactly. Over time, in general, you can use them, all of them. But the idea when I said that you can use volume, because you are going to have a map, an interactive map. You can plot like each information that you have with latitude and longitude. You can put it in the map. Yeah, for doing forecasting and the last one, Seaborn and the Plotly are the most used there. And we're going to see a small example of it, how you can do it. So again here, you can find all the materials in my GitHub repository into this file. I put you the whole libraries, which one with a lot of details and going through the whole thing. So don't worry. This is why I'm trying to go with a small example through these different libraries. But if you want a really complete course, you can find this for each library. You can find the whole functionalities going from different charts, and you can see how you do it with the customization and everything. So I'm not going to do it again here because it's going to be boring, but you're going to have all the materials. You can do it by yourself. It's amazing. You have all the thing exhaustive here. You can see I'm going through the whole thing with the commented. I commented everything. But here, what we're going to see is a small example with 2 real data sets. And we're going to see some examples. And then we're going to move to the most important part, which is Docker. So yeah. Yeah, GitHub. Yeah, you're gonna find all the the whole workshop series, by the way, either for the AI, deep learning, machine learning, and the data visualization. I put everything there. So again, it's gonna be boring going through the different visualization. So you're gonna find the complete thing for the different libraries: Matplotlib, Seaborn, Folium, Plotly, Streamlit, and also for geographical map here, generating maps. So here, what you're gonna try to do is going through 2 different data sets, which are the first one. Let me just get like this. Okay, so we're gonna start with some examples using Matplotlib, going through Seaborn, then Plotly, then using some examples for Folium, and finally Streamlit. I'm gonna use for this 2 different data sets. The first one is related to, they are both data frames, so we have already seen this, the iris data, and another one which is the immigration to Canada. We're gonna see this. So quick start here, just a small example of an anatomy of figure, just in case. You're gonna have the figure here, and you're gonna have the title, legend, the axis, and we call this the minor tick label. This is what a figure looks like. So first, when you are working with tabular data, we have seen this. We're going to use Panda library to read the CSV files and to get the data frame. So again, you're going to have this kind of data frame, which represent the immigration to the Canada. You have the country, continent, the region. Is it a developing region or developed? And the years, from 1980 to 2013. And the total here, number of immigrants. So if you start with the basic plots, which is matplotlib, again, line chart, it's in general used for time series data. Again, time series, which means, for example, if you are looking to do some monitoring or forecasting for dioxide carbon, this is where, in general, we use the line chart. And here, for example, to show you an example, this is an example of how you can use the data frame to show the total immigrant going from 1980 to 2013 with the total immigrant to Canada per year. This is going to be giving you an idea of how many. Then you can go further and select a country. You can filter by country, for example. You can see the trend for India here just by selecting, because it's data frame, you're going to select the country name. And you're going to have these kind of plots. It's going to give you a filter here. Now, you can go further and do some subplots to see, for example, and get some insight about the top 5 countries. You can see here that it's India, China, United Kingdom, Philippines, and then Pakistan. It's going to give you an idea. Now, same thing for the iris data, if you remember. The iris data is going to give you, you're going to have 3 species of flowers. Each one going to have 50 samples. So we have 3 classes, as you can see here, Setosa, Vergicolor, and Virginica. And you can see that for each class, you're going to have 4 parameters: sepal length and width, and petal length and width. So again, line chart, you can use it to see, for example, the different samples here, 150, and you can see the sepal length, how it evolved, for example. Same thing, now you can use the subplot to create something like this, which gonna give you some insight, because here, just by showing this, you can see that this is here, the Setosa here, class, it's linearly separable. It's easy. When you are working with machine learning model, for example, it's gonna be easy for him to classify this kind of class. So it's gonna give you some insight. This is why it's important to visualize your data. Now, you're gonna move to bar chart. Bar chart are the most common type, it's the most common type of visualization. They are used to display and compare the numbers, frequency, and you can see it here, for example, with the top 10 countries by immigration to Canada. You can see it that is easy to read when using bar chart. You can see this. Here you have the countries, and here you have the number of immigrants. And it's easy to see that top 5 are here. You can use it also, but this time by continent. This is how you can play with your data, for example. By continent, you can see that Asia is the most. One have the lot of number of immigrants here to Canada. Now, you can go further and using bar chart, but this time by grouping the continent, but you can add some information about the year this time to compare. For example, 1980, 1990, 2000, and 2010. And it's going to give you an idea. Same thing here. Now that you have this information, you can create something like this that you can use to report or document if you are working for a company, for example. It's going to be easy to interpret and understand your data and to get some insight of it. Same thing for iris data. You can create exactly the same things. Look into the bar chart for the different category. You can see that you can stack also this bar chart here and compare the different category here, different classes. Now the next one is scatter. It's very used to show a relationship between 2 numerical variables, but again, scatters is very used to do some clustering, if you remember, using machine learning. Now, in our case here for our data, it doesn't make really sense. I plot you here some figures, but it doesn't make sense. You can see that the scatters here just showing the developing region and developed by year, per year here, as you can see, but it's not adapted to our data here. Same thing here. You can see that by countries, the continent, I'm using scatters, but it doesn't make sense. This is why you need to really know what you are doing, not just plotting. For the iris, on the other hand, it's gonna make sense, because you're gonna have something like this, which is amazing, because now, just by looking at this, I can see that, again, it's easy to separate the set of the class when working with clustering algorithm, like k-means. It's gonna be easy for him to use, for example, these two parameters, the petal width and the sepal width. Because now I'm plotting the whole combination of our classes. And you can see that this one, it's easy to be separated. Or this one, for example. This is how you can get some insight. The scatters is very good to do the clustering one. Next one is pie chart. Pie chart is, for example, some use cases displaying market share of companies representing election results, for example. Here, plot you here the distribution of immigrant by continent. You can see the percentage by continent. Same thing for the iris, but for the iris it doesn't make sense because we already know that it's 50 samples for each. Next is histogram. It's very used to look at the distribution of your data. It's very used and important when you are working with images, because sometimes just by looking to the distribution of your pixel intensity, you're gonna find that your image has kind of noise, like Gaussian or gamma, that you can use to do some classification, for example. So it's very important. Here, okay, it's gonna give us some idea about the distribution of total immigrant by country here, the number of countries, and the number of immigrant here. And you can do per year and do a subplot that cover the whole thing. For the iris data, you can have something like this. Again, it's good to have this because now we have that, we know that this can be fit by Gaussian distribution and it can be separated easily. So it's gonna give you idea. And you can do stacking like this kind of figures. Next one is seaborne. Now, again, seaborne, I told you to do this when you are using statistical analysis because it's gonna give you more details, but it has already some regression model on it that you can feed, but it has also some figures like this one, the heat map, which is very interesting when you are working with the data. It's gonna give you a quick overview and easy to be interpreted. As you can see here, by year, you can see that India and China are the most, where the total immigrants are very high here. So it's gonna give you a quick idea using the heat map. Again, it allows you also to do some clustering immigration to see some relationship between these. Now, there are other features like box plot and violin, which gives you also a good overview in order to detect the distribution and the outliers. These two kind of plots are very good to detect the outliers. And then finally, you can have the pair plot, which gives you a combination of a relationship between the whole data using scatters and distribution. Here, in our immigration dataset, doesn't make sense. But you're gonna see that using iris, it's gonna make sense. And this is how you can fit already using a model provided by Seaborn your data. If you have something like this, you can have the regression linear function here. It's gonna give you already this. And by continent, it's gonna be the same thing. It can fit your data. So it can give you, before you're gonna start working on machine learning models, an idea how you can fit your data, a quick view. For the iris, same thing, you're gonna have the heat map, the box plot and violin to detect some outliers like this one, the regression for your data, which doesn't make sense here in our case. We don't want to do a regression for our problem here. I'm going to do some clustering one. It's clustering problem. But if you look at to the pair plot, you can see here this is very good visualization because you have the different distribution. And again, you have the 4 parameters for each class. And you have the quick view of the different distribution and how you can separate these classes. Which one is the best to be clustered? Which parameters are you going to use? Now, next one is Plotly. Plotly going to do exactly the same thing, but this time interactively. So you can see that it's interactive. Your plot is interactive. You can select the home here. You can zoom, hover, give you some details, as you can see here with the name. You can choose the legend and work on it. Remove this, remove this. You can see that it's very interactive and very used to create dashboards. This is the most adapted one. If you want to create some dashboard, you use Plotly always. Now, same thing here. You can see that we can do, so this is the line chart, as we have seen. But you can see that for the bar chart, it's going to be the same. But look at the details here. For each continent, it's going to give you the country and the total number. You see? So it's a lot of details going on. So you can zoom on this for Asia, for example. Or you can remove one of them. And it's going to do the classification again, you see? So it's very interactive. It's very used for dashboards. Again, you can create something like this, which is interactive. It's going to be, if I select Asia, it's going to be related to this, South Africa, South Asia, you see, India, Pakistan. So it's very interactive. See how you can manage this? And finally, you can create also plot like 3D, like this one, and filter this by country and by continent if you want. Again, this is very adapted to dashboards. And here, if you have, as you asked, some time series data and you want to see the evolution, you can create something like this, and you can play it, and you can see the difference, how it evolved over time for the different country and the different continent. And again, you can use all these to be implemented into a dashboard. Next one is Folium. Folium is for creating maps, interactive one. So if you look at our data set, you can see that we have the longitude and latitude for each country. So you can plot something like this, just to show the different country that you are working on. Then you can create something like this with a color map. Okay. I lost the IBEX resources. Let me ask again. Yeah, I lost them. Let me just check. I reduced. Okay. You can see that asking for the HPC is something here. Okay. Let me try. Maybe less. 30 minutes. Ah, okay, I got it. So let me run. This is a good example to show you that here, for example, I'm using alternative to Docker, which is Podman on Ibex. I'm running my Jupyter notebooks using this. You're gonna see how we can use Docker. Okay. Right, and I have my okay. All right, so we were here. Let me just make this. So again, you can use Folium to display if you have some knowledge or information about the longitude and latitude of your data, and create something like this using a color map. To illustrate the number of immigrants by country and by continent. You can see here. You can choose plot it or to remove it. And you can go a little bit further by doing all this in one map, create something like this with a heat map, a small legend that illustrates the cluster of markers, and the heat map. And you can see that if you click here, it's going to give you by country the number of immigrants. So it's very intense. You can see here, you can select the cluster, you can go here and have all the information. This is the kind of thing that when working with the geospatial data, you can use. You can see here the different clusters, and for each marker, it's going to give you the details, and you can choose here the different type of tiles. Here, you can use this one or the OpenStreetMap. If you are like it, you can plot the markers, remove them, heat map, plot them. So it's very interactive. You can see this. And finally, when you have all your visualization ready, you can create a small dashboard for exported data analysis, like this one. Let me just remove this. Using Streamlit, and it's going to give you something like this. Small dashboard to illustrate your exploratory data analysis. Here you're going to have the settings. You can make it look white, choose the different tones like white or dark. And here you can see an overview, for example, the different visualization that we have been using for Plotly, using Plotly. You can see that now it's interactive, and you can either choose, for example, this one, look at it alone. You can save it, download it as PNG from the dashboard. Then you can select another multi-page where you can do some stuff like this one, add others country to your analysis, or remove them, and it's going to give you the idea here. You see? Or you can create export your data analysis dashboards. And then you're going to add the geospatial view. So the two different maps that you have already seen here. So again, and it's running locally, exactly, we're gonna see this, how we can do this kind of stuff. But again, if you wanna really learn how to do this kind of thing, just go to this. I put it in the GitHub, Streamlit, notebook. You're gonna find the whole thing from the beginning. Like how to create an example here, a text. And I'm giving you all the details here for each widget. So you can see here from the text input, I'm covering everything. But it's gonna boring going through this. So this is why I'm giving you an idea here. So you can create dashboards like this one to do some EDA, but you can now, for the iris flower, for example, you can create a machine learning app using, again, Streamlit. And it's gonna give you something like this one. We have seen this in the previous courses. So we have our application that does the iris flower prediction. We know that we have 3 classes. We built a random forest in order to do the classification here. You can play with these different parameters of the model. And then you're gonna have the prediction, something like this one. For each new flower that you wanna predict, you can see that the prediction is gonna be different. You see how it's interactive? Now, based on these input parameters, it's predicting that it's Virginica. So you can see that it's interactive. And you can use different parameters for training the model. And it's going to give you the prediction in real time. This small app of the iris flower. Now, again, you can do, if you remember, the heart disease prediction app, which is a little bit, need to go a little bit further for that. It's going to give you something like this. Very complete app to predict the heart disease. For that, you're going to upload your CSV file. You're going to have your data frame. Next step, we have seen this, data cleaning. So you're going to clean this. You can create something interactive like this one. I'm cleaning the data. It's giving me the cleaned data. You see it here? You remember the one-hot encoding? Next one, we're going to go to the training. You can create something like this in real time. You choose the model that you want to create and fit your data on it. Random forest, regression, support vector machine. Here, you can choose the different parameters for each model, and you can train it. And it's running locally, you see? And give me that my model was trained successfully with an accuracy of 90%. Amazing. And it's going to give you some visualization like this one to get the most important features used in my model. Then you can make some prediction on new patient. So the new patient came. He has new parameters. You give the age here, all the different parameters. You can select them, play with them. And you can make the prediction. And for this patient, for example, it's positive, a 90% probability that he's gonna have heart disease. And again, you can play with it and make prediction, and it's gonna give you something like this. This is the kind of application and dashboard that you can create using Streamlit, which is very easy to learn. Now, just before we finish, you can create also something like the one that we have used for food vision application. You remember the last one? To predict using a deep learning model, but using a pre-trained one, so transfer learning, if you remember. We have used this. You can create something like this, food vision app, to train new classifier on new data, or use pre-trained one, like the one that you have already used for transfer learning. Then, let me go to the folder. maybe here. Okay, now I have some images. If I put Solomon, it's going to predict that it's a grilled Solomon with a confidence of 94%. All right, so you have your application running, right? Here, the next step is to share it, right, to your colleagues. The problem, if you are working with your own environment and all your Python program and all this stuff, how are you going to do it? Are you going to give them, yeah? It's a library, Python library, yeah. Sorry? Yeah, exactly. This is why it's interesting to use it, because we are always in the Python environment. We didn't get out of it. All these are Python libraries. Sorry? Yeah, but a bear, because it's adapted to be used using the Python libraries, which means you can use TensorFlow, PyTorch within it. So it's easy to implement all your API. Like, it's a library that can be used with all the libraries for deep learning and machine learning, which is amazing. So again, you want to share your work. The problem is that you're going to need to give him all the instructions. Do the installation of Streamlit, pip install Streamlit, or conda environment, or all these things. The problem is that it's not going to work for him. He's using a Mac. You are using Windows. And this is gonna tell you, I'm getting some, I don't know, conflict dependency on this library. It's not working for me. But you're gonna say, but it works on my machine. So how are you gonna do it? Here where it comes Docker. This is the most important part. Docker is it's a must nowadays to learn. With Docker, you can avoid this. Let's see how to do it. So if you take here, so again, what is Docker? Docker is just an open source platform that's gonna allows you to run and work on your own application or environment and deploy it as a lightweight, portable, self-sufficient container that will run virtually anywhere. And this is amazing because it can be run on Linux, macOS, Windows, WSL, which I'm gonna use here for the demo, Windows subsystem for Linux. And it's gonna allow you to create your own application or own, I don't know, project that you are working on your own local machine, and then share it or deploy it on other operating systems, which is amazing because you're gonna be able to create a consistent environment that's gonna work everywhere, which is amazing. This is what you are looking for. Now, here, again, if you can install Docker Desktop, you're gonna do a small exercise on it. Just go to Google Docker Desktop and install it. And these are the most common and important commands. We're gonna find the commands related to the images. Images means the environment that you're gonna create and that's gonna include all the packages that you're gonna work in order to run your application. So for that, you're gonna find Docker build to build your image. Image, again, it's an environment. You can see it like this. You're gonna have Docker images to list all your local images. Then, if you wanna remove the image, you're gonna use Docker RMI. And if you want to remove all unused image, you're gonna use Docker Image Pro. Then you're gonna have some commands related to the Docker Hub. Docker Hub is a service provided by Docker for finding and sharing containers images. You can see it as GitHub. This is where you can push your own images, so your own environment, on Docker Hub in order to share it with your colleagues. And for that, you need to log in into it using your username, of course. Docker push to push your environment into Docker Hub. Then you're gonna have Docker search to look at for the environment that you wanna work on it, and Docker pull to download this image. This is an example here, just to show you. If you go to Docker Hub, it looks like this. And you're gonna find all the images that you're gonna need. For example, I'm looking for Ubuntu, right? You're gonna find the image too with different release. And you can just go here and do docker pull Ubuntu to download this image and to work with Ubuntu. Imagine I wanna work with Debian. You can find it. You see how it's easy? Now, you are a data scientist. You wanna work on some data science environment. Just look at to the Jupyter, and it's gonna give you the different environment using Jupyter for PySpark, TensorFlow, or maybe data science. This one looks good for me, and you can just download this and pull this, and you're gonna have the environment of Jupyter using data science. So you can see that it's very big community working on Docker. And you can find all the environments that you're gonna be interested in. Now, the last commands are related to what we call the containers, which means the instance that's gonna be run using the Docker image that you downloaded or created. You're gonna see how to do this. And you can see it as a process, an instance that you're gonna run using your environment as a process. And for that, you just need to do docker run, and you put the Docker image here. And it's gonna run a process using this image. Ubuntu, mini Conda environment, you're gonna use wherever you want. Now, there are some parameters. You can add a name to this container, a port to publish a port between your host machine and the container. You're gonna see how to do this. A volume, which means you're gonna create a bridge between the container and your local machine in order if you wanna, for example, work on your local scripts that are in your local machine. You can create a bridge using the -v here. You're gonna find also Docker start and stop to start and stop the container, Docker run to remove it, Docker execute to execute it again, and this one, Docker PS, very interesting to list all the running containers. PS means process. And again, Docker PS all to list all Docker containers. Now, this is a common workflow. You're gonna go to Docker Hub, find an image that you wanna work on it, pull it, which means download it into your local machine, run an instance using this image, work on your scripts, do the job, stop this instance, remove it, and remove the image. Again, here we are talking about finding an image in the Docker Hub. But you can see later how you can create your own images, which is amazing. Because this is how you're gonna share your application. Gonna work on something on your project, create your own environment, Dockerize it as an image, and then it's gonna be easy to share with your colleagues. Now let's do a small Docker demo. Let's run, yeah. Yeah, exactly, this is the idea. You can already work on some images that you like on the Docker Hub, and you work on it, and you add some libraries, and you don't have to do the whole thing again. You have your, for example, Jupyter Data Science image that you like. You can add some libraries like Streamlit to it, and then you save it as a new image, your own image. This is the idea. Now, we're gonna try to run, of course, the most obvious one, the hello world image. Then you're gonna try to run an Ubuntu image, but this time to display the hello world using the Ubuntu, using a bash script from inside the container and from outside. This is the steps that you're gonna try to do. For the hello world, first thing is to pull the image, run the container using this image, see if it's running or not. And for the Ubuntu, we're gonna go through these different steps. Again, if you installed already Docker, we're gonna do it again, together if you want. Then you're gonna have some more exercise. I'm gonna help you with this. But this is the idea. So here, if you move here, if you already installed it, I'm gonna use here WSL, but in your case, you're gonna have what we call Docker Desktop, this one. So either you're going to use your terminal for it, or if you don't want to use your terminal, you can use the terminal provided by the Docker desktop here, as you can see. So if you go here, just to see if you have installed your Docker, just put Docker. It's going to give you all the information here. So it's well installed. The first thing, as we said, is to look at the hello image. So for that, you do Docker pull hello world, right? Now it's going to go to the Docker Hub and download it. Now I can do Docker run to run an instance using this image. Let me just. All right, it said hello from Docker. This message shows that your installation appears to be working correctly. So you should have the same thing if you do the same steps. Docker pull to download the image, Docker run to run an instance using this image. It turns out that the image hello world just plot this. All right, now we're going to do this time same thing, but using Ubuntu image. For that, again, same thing. Docker, we said Ubuntu, right? We have already seen that it's already in the Docker Hub. It's gonna look at this. I already downloaded. So, I remove it so you can see how it's downloaded. This, so I have it in my local machine. How I can see this? Docker images to list all your local image. I have a lot, but you can see that the latest one here, it's Ubuntu. I already downloaded it. You can see it here. Now, imagine you want to look to the running container. For that, Docker PS. OK, I have a container here running. It's open web UI, as you can see. And if you want to see Docker PS all your containers, previous one, you can see that here, the previous one, hello world, is here to list all the stopped. And you can see the state exit. So it's run and stopped. OK. So again, Docker images, Docker PS, and Docker PS minus all. Each time, use this. Every time. Yeah, in the background, exactly. No, this one are stopped. The one here, Docker PS, is running on my background. This one is running. And Docker PS minus all, it's going to give you all the containers that you have launched and run. Now, again, we downloaded the Ubuntu image. Let's run a container on it. Docker run using Ubuntu. OK, what's going on? Nothing happens. And it's OK, because why? Let's see, Docker PS, OK. Only my container is running here. But if I do Docker PS minus all, now it makes sense. You can see that I already run something using the Ubuntu image, as you can see here, 20 seconds ago. And it's run something. The problem is that I didn't give him any job. Just said, OK, run Ubuntu. Didn't give him anything. So he launched the instance and he quit. This is that. He didn't do anything. But in reality, he did. He ran instance and he stopped. I didn't give him any job. Let's see now if I do clear this, Docker run. But this time, I will add parameters, which is 80, which means in terminal. And I will add a name to my container. Call it Ubuntu hello. And then I will give him the Docker image. Okay. Now it's giving me something. What's this? It's a fresh Ubuntu. You can see it. You can see all the files of my Ubuntu. It's a fresh one. And if I do this, for example, like look at to the OS release, you can see it. It's giving me the release of Ubuntu, the 24.04. You can see it's a fresh one. Amazing, right? Now you have an Ubuntu. I could use Kali Linux or I don't know, Debian or anything. It's a new one, fresh one. Okay, now you can see that I can use echo hello, for example. Let's create our batch script, right? We want to display hello world from inside the container and then outside. For that, we're going to use nano, right? hello.sh. Command not found. Why? It's fresh Ubuntu. It has nothing. So for that, before we do this kind of stuff, we need to do apt update, right? Let him update this packages. Then apt install nano. Now, if I do nano hello.sh, it's gonna work. All right, perfect. So we can do this kind of stuff, right? Hello world. Then again, if you don't know how to use nano, Control O. I don't know if it's the case for Mac users, Control O, and then Control X. All right, if I do a list, I can find my file, hello.sh, right? It's here. So if I do bash hello.sh, it's gonna work. Print, so I run my bash script. If you have other scripts, you can run them using your machine. All right, perfect. I finished my job. I wanna quit. I will do exit. Now I wanna run these scripts from outside. Yeah. Not really, yeah. Virtual machine, you're gonna need to put a lot of requirement to it, like a number of RAMs and memory and all this stuff. Here, it's already using your own things. You don't need to put anything. Yeah, this is a small difference, but yeah, of course, there are many differences. But this is the most important one in your case, like. Exactly, yeah. You can use everything, so it's amazing. You have to manage all these things, but here it's gonna use all the thing, run the process, and quit, which is amazing. This is the idea. Now here, if I wanna run the same script, but this time from outside, how to do it? In your case, I will do this, docker run, Ubuntu, right? And add a bash hello.sh, right? You're gonna do this. It makes sense for me. Is it gonna work? Let's see. No such file. Why? He didn't find it. Why? The idea I told you, each instance is independent. It's isolated. It's ephemeral. This is the idea of running instance. It's ephemeral. Each container is separated. There's no relation between the containers. So here, in order to run my bash script, I need to find the previous container. For that, we have seen this, docker ps, not running, so docker ps minus or, right? Now, here is my container. We call it Ubuntu hello. So for that, in order to use it again, you need to start it. We call this docker start. Docker start, and here, if you want to start a new a container, you can use either the ID or the name, as you wish. Let's use this. Okay, I started my container. How I can check this? Docker PS, right? I can see he's running. Stay tuned up. 7 seconds ago, he's running. Now, if I do docker run and put this name to bash hello.sh, I didn't. He didn't find. So, running. Let me just. Here. There is a trick. Even me, I forget about it. In order to use a running container, you should not use docker run. You should use docker execute, because it's already running. So for that, you're gonna need docker execute instead of docker run. Run is gonna run a new process. Execute is gonna execute what I've already run. So here, you put the name, and this time, if I put bash hello.sh, it's gonna work. So I'm running my scripts from outside the container. So if you have some scripts on your container, just run them from outside and you have your process. Amazing, right? Now, you finish your work, you run your script from inside and outside. You wanna remove this or thing. What you need to do, docker aram, right? To remove the container, this one. Let me just take the ID is better. Docker aram, and you want to remove it in order to remove everything. Exactly, this is the idea. You cannot remove a container. You need to stop it, remove it, and then remove any container using a Docker image in order to remove the Docker image. So these are the steps. Stop the container, remove all the containers using the image, then you can remove the image. So here, for that, you need to do docker stop first. It's gonna stop the container. How you gonna check it? Again, always use docker ps. So if I look at the docker ps, you can see that it stopped, right? Docker ps all. Okay, you can see that 3 minutes, it stopped here, 9 seconds ago. And now, in order to remove this Docker image, which is Ubuntu, I don't need it anymore. I need to remove each container here that use this image. For example, here, Docker aram. And you can see that I already used 3 containers, right? This one, this one. You can add them like this. All right, I delete them. Now I can do docker rmi, remove image, and I put Ubuntu. And it's gonna delete it. Now if I look at the docker images, I'm not gonna be able to find it again. This is a small workflow, how you can use Docker. Now, it's your turn, I'm gonna help you, but I want you to do this time exactly the same thing, running, instead of bash script, a Python script, but this time not using Ubuntu image, but using Miniconda. So do exactly the same thing. Download the image, this is what you need to do. Try to download the images. I'm giving you some hints. This is the name of the image. Then run a container using this image and name it my first Python script, for example. Then create these Python scripts, and inside this container, call it hello.py. Put whatever you want. Print, I don't know, hello world. And then execute these Python scripts from inside and outside. And finally, you can delete it and delete the image. Let's see how, if you can, I'm gonna help you. So we're gonna start by doing this. Try to do this, and I'm here to help you. And again, I'm gonna give you some hints, and you can try it. Again, if you wanna, it's already there, Miniconda, but if you wanna look at it, go to Docker Hub and look for Miniconda. You're gonna find this image. Again, if you need any help, I'm here. We can do it as well. Go to Docker Hub, look for the image. You have the name, Continuum Miniconda. Yeah. You can use whatever image you want. It's not Miniconda. You can use Anaconda, I don't know, whatever you want. You've been able to install Docker? I wasn't. Ah, you have the admin right? It's related to the system here. No, Ibex. You're using Windows. You have Windows terminal? Yeah, let you get to the terminal. Okay. Were you able to do it? Okay, it's working. Perfect. So let's try to do it. Go to Docker Hub.
Can I?
Yeah, of course, this is the idea. Again, another thing. If you don't have the image and you don't want to do the Docker pull, then Docker run, you can directly do the Docker run, and they're going to know that you don't have the image, and they're going to pull it for you. So here, for example, we said Miniconda, right? You can use whatever you want. Yeah, this one. You see? Now here, we're going to have this command. And copy it. You have everything. You can do Docker pull. No, it's gonna help you a lot. I'm gonna tell you. They are either you're working on AI or data science or other fields. It's gonna help you a lot to create a consistent environment that you can share with your all colleagues. Yeah, it's amazing. Now it's downloaded. It's working. You can work here. Yeah, it's amazing. It's amazing. Docker containers are amazing. So print hello world, perfect. Control O, Alex. So you are inside the container, right? Run it, Python. Yeah, because you are using Miniconda image. So it has already Python on it.
Oh.
This is the idea, you see? Now if you run this, yeah. You made a mistake because you forgot here the bracket for the print in the script. You see? Amazing. Now exit and try to do it from outside. Did you put a name for your container? Right, Docker. Okay, it's running.
Yeah.
No, it's already exited. You need to start it. So do Docker start. The ID or the name, as you wish. Okay. Do Docker PS. It's running, you see. Now do Docker execute. Okay, guys, just to help you, I'm gonna give you the instructions for the previous one, and you can adapt to it. So you can see it here. This is gonna help you. This is another hint. You have all the commands that I've been using for the Ubuntu. You can adapt it to your Python script. All right. So Docker execute. Do it. You see? Either the ID or now you are executing from it. And he did the job and he quit. Now you can remove everything and you see? Let me. Able to create?
Yeah, I mean, I will do
Docker. Yeah, but before you do this, give him a name.
before. Okay.
Minus name. My Python script. This is the name of the container.
Yeah.
Then you're gonna have the image. But here, it's gonna do nothing because you didn't put the minus IT in terminal. But now, it's already run and executed. You need to start it again. So look at Docker PS. You can see nothing is working. Do Docker PS all, minus all. It's already there. So take it. How did you call it? The name is here. Yeah, you call it this one. So do Docker start and put the name. Yeah.
Okay.
To start the container. Now we are working with the container. You get it?
Yep.
Now you can do Docker execute. Minus, no, exec, just, yeah, like this. Do minus IT, the name of the container, and do bash to enter into the do Docker. Yeah, it's not running. Did you do the Docker start? You didn't put the right name.
No.
Do Docker PS. I didn't start. Do again, yeah. Create another container Docker right? Minus IT. Name. First. Okay. Then minus IT. Do minus IT. Then do the image, yeah. All right, you are inside the container. Now create your Python script. So for that, nano hello.py. Problem is that I don't know if you're gonna find the nano. You need to do apt update, then apt install nano, run it.
Yes, this Minicon
Yeah,
works on Linux.
exactly.
So each image contains some operating system.
Exactly. Exactly. But you can choose an image. Yeah, exactly. This is the idea. It's already there. And Ubuntu is already there. Operating system. And they installed Miniconda on it.
Yeah, now
You get it? So do yes. And here you can find all the steps. You can do exactly this, but adapted to Python. So for that, you need to do apt install nano again and create your Python script. Nano hello.py, put print hello world, save it. Yeah, it looks like you are working with Control O, Control. Now he's gonna be able to run it because it's a Miniconda environment, so it has Python on it.
Oh. Yeah.
You see? And now try to run it from outside the container. Were you able to, to do some stuff? No way, you don't have access to... Yeah. You don't have access to the iCompass guest, I think. They didn't give you the access? No? I was gonna take you all your data. I can stop it. Don't worry. You cannot. You cannot. You need the admin rights. You don't have it?
No, I do.
Do? Ah, okay. But perfect. Yeah, again, you need the admin right to install Docker desktop. So I don't know if everyone here has the admin rights, but you need them to install the Docker desktop I'm talking about. Yeah. If it's a custom laptop, of course. Were you able?
To run it from inside, but now from outside. No?
Show me the Docker PS. Where is the... How did you call it?
Mini Honda.
Exercise.
Yeah.
All right. So it's running. Ah, it's exit.
No, but
can see.
the one. This is when it's running, right? The one on top. No.
Do only Docker PS. You see only the container running. Okay, this one is running.
Yeah.
So now, in order to run something on it, do Docker execute, exec, put the name of the ID, yeah, exactly, the same, okay, and do Python, the name of your script, I think.
Okay, yeah.
Working.
Yeah, so maybe
You see?
typing something. Okay.
Yeah. Oh, it's working. Are you able? Using the Miniconda?
Yeah, inside and out.
Inside and out? Perfect. Now you can remove everything. You need to practice because in order to get the commands. So in order to remove it, don't forget, stop any container running container using this image, remove the container using Docker RM, and then you can remove the image using Docker RMI. How it goes? Are you able? Tell me.
We already installed Docker.
Yeah.
Right. We first applied Python and rolled.
I already pulled the image. Amazing. Do Docker PS just to check if you have any running container. Okay, perfect. So now run a container using this image. Just do Docker run. I'll let you. Docker run. Run. Then put a name, minus name. Put a name, I don't know. Python script. This is the name of the container. Then do -it to be into the terminal of the container. Then put the image. Yeah. Okay, you are inside the Miniconda image.
Okay, yeah.
You can see it. Here you have all the operating system running, and you can see that Python is there, so you can run it. Now you can create your Python script with a nano. But again, it's a fresh container, so you need to do apt nano, apt update. Then apt install nano. Do it, yeah, the update, to update the kernel of your image, then do apt install. Okay.
I usually use Vim.
Do Vim.
Okay.
You can do it. Do it. Now it's gonna install Vim. Then do Vim v. Call the name, I don't know, python.py or I don't know. hello.py. Do a print hello world, print bracket. Don't forget the hello. Control, I don't remember to do it. Okay. Now if you do the ls thing, you're gonna find your Python script. Do Python run it. You're gonna see that this is gonna work because Miniconda has already Python on it. It's running, perfect. But you are running it inside. Try to run it outside this time. Do exit. Okay. Now, in order to do it, check always the state of your containers. So do docker ps. Now container, yeah, exactly. Do docker ps minus all minus a. Do it. Okay, you have an exited one, the one that you called Python script.
Yeah.
In order to run it again, do docker start this container, either using the ID or the name, as you wish. Okay, docker ps to check the state here. Okay, it's running.
Yeah.
Now do docker execute in order to execute something on this exec, and put the name of the container, ID or name, same thing. And script. And then Python, so the command that you want to execute, and the script. Hello.py, or don't remember how you call it, right? This working. Come out.
But I first need to create the barrel.
Yeah, exactly.
This file is not in my.
This is the idea.
I mean,
now we are
in my
trying
real
this. But the next step that I'm going to show you is how you can work with your own local file by creating a bridge of volume between the container, which is amazing because now you can create a Docker image that contains libraries that you are interested in, but you don't want to install it in your own local machine. You're going to use a container to run your scripts to test this kind of libraries. Now you should show her how to do it.
I do.
Exactly, this is the idea. All right. Everyone get it? You're on nothing. Okay. You're able? Not.
No.
I'll do it. Okay. Okay. You are inside the container, which is amazing. Yeah. Local script, right?
Sorry?
Local script. Local script.
Yeah.
Your own local scripts. You want to run something on them, right?
So if I want to run like
Exactly. This is the idea. And the next move that I'm going to show you is how you're going to run using your own local scripts on your own local machine, but this time using an image or libraries that you don't want to install on your own local machine, you know? So you're going to take one image that contains already the libraries and your own script using a container, and then that's all. You didn't install anything. This is why it's amazing. Docker is, it's a must nowadays, yeah. Help? Or it's okay? You're able to do it? Yeah? I think, all right. Still downloading the oh, you're all done? Okay. Let's run. Okay, let's do it with Anaconda. So here you have already your image. Do docker ps. just to check if any. Okay, do docker ps minus a, docker ps minus a. Okay, now run a container using this new image. Do docker run, then minus it in order to be into the terminal, then minus name, call it,
My first.
yeah, my first Python script. You forgot the name.
It should be never.
Name, space, then docker run, put the, okay, then put the name of the Docker image that you already downloaded, the new one. This
Oh, this
which
is
one
the
did
name.
it? Yeah,
Oh,
this
for
one.
the context.
This one. Okay, now you are inside the mini conda Docker image. All right. For that, you need to create, for example, bash, not bash script here, but a Python script. For that, you need to update, do apt update the kernel, apt space update to update kernel of your Docker image. Okay. Then apt install nano. Okay, apt install nano or vim, wherever you want. Now do nano and create your Python script. Call it hello.py. Hello.py. Okay. Now you can create your Python script. Put brain rocket like this, and then put the two hello, for example. Yeah, quotation, but do the yeah, this one exactly.
Remove.
I think you should remove the space between print. Yeah, there is space now. No. Okay.
It's already space.
Ah, okay. Yeah, but you should remove it now.
No. Should be.
I think something like. And do the. Now do Control O. Okay, and Control exit. Now you should be able to find your hello.py. And if you do Python, because it's an Anaconda image, already included Python on it, you can do hello. And it's gonna work inside the container. Try to do it outside. For that, you need to exit container. Look at Docker PS to see if there is any container running. Nothing. Docker PS A. Yeah, that's it. Okay. Okay. You call it Python script. Start it again. Docker start.
Docker run or docker
Start. Because you want to start your old container. This one. Choose the name or the ID as you wish. Don't forget the T. Do it, you're gonna see. Okay. Now it started again. If you check Docker PS, it's running. Perfect. Now, in order to execute your script, do Docker execute, because you wanna execute something using this Docker exec. Then put the name of the ID or the name as you wish. You can work with the ID or the name of the script.
Both will work.
Yeah. Now No, it's not gonna work because you need to give him a job. For that, you need to add the Python. Hello. Dot py, right? Now it's gonna. That's from outside. Now you can remove it and remove any script and yeah.
The name.
Yeah. To call it.
So here now, folder.
Do docker ps just to check if there is anything running. Nothing. Do docker ps all minus all. Okay. Okay. You have some running. If you don't give him a name, it's gonna choose one by default. But I want you to create a new one using your
Docker
run
run.
minus IT to be into the terminal, then minus name. Call it wherever you want. Perfect. Then you should put the name of the Docker image. This one. Just copy this, yeah.
Like this.
Like this. Run it. Okay, you are inside the container of the mini container.
Okay.
Now,
Want to start?
apt, yeah, but before you create your Python script, you need to do apt update to update the kernel. Then, okay, apt install nano. Perfect. Now do nano hello.py, your Python script here.
Okay.
Do print bracket hello world. You should need maybe this one, but that one, yeah. I don't know if it's gonna work. You need the other one, the one with the
like this.
yeah. Okay. Control O, exit. Command O.
Should be, right?
Yeah.
Okay,
Command O and then command exit. Enter.
It is control.
And then command exit.
Yes. Why, right? And
I don't know if it's control or command. I'm not a Mac user.
okay, so now maybe
I don't,
how we can
do Python and run your script if it's gonna work. So because the mini conda has already Python on it. Do hello.py, the script that you create. It's working, right?
Okay,
Now you did it from inside. Try to do it from outside. So do exit. Don't forget. Then do docker ps -a. Take your first code. You see it stopped. Started again. So do docker start and put the name. Perfect. Do docker ps to check if it's running. Amazing. It's running. Now execute your Python script from outside using this container. Do docker execute this time. Docker exec. Remove the D. Name of the container or the ID as you wish.
This one. Container.
This one, the running one. Either this one or the ID as you wish. You can work with both. And then you need to give him a job. So Python hello.py. Perfect. Or you can remove everything and yeah.
Created container with the name of this.
This is the second Python, okay?
Yeah. And how can we directly access for this container and then to enter this text from terminal?
Yeah, you can do this. Not look at always do Docker Yes,
I think
it's a Docker PS. Ah, you already.
Yeah.
Let me. Docker PS. Nothing is
Yes.
running.
Yes.
So we do Docker PS minus A.
Yeah.
We check the state.
Yes.
You wanna this second Python, right?
Yes.
For that, you need to start it again. So you do Docker
Okay.
start, right?
Yeah.
Start, and you put either the name
Yeah.
or the ID.
Okay. Yeah.
So I don't know how to copy. I'm not a Mac user, so do it. Look.
This
All
one
right.
is fine.
Exactly. Start it again. Perfect. If you check the state you now, it's running.
Yeah.
And you want to be inside it
Yes.
again. For that, you need to do docker exec always. But this time, you need to add minus ID to be into the terminal.
Okay.
You put the name of your Python. Okay. And you add the job, which is here in your case, you want to be inside. So you add bash. And now you're inside it.
Okay.
And now if you list, you're going to find your Python script if you created one.
Yeah.
You can remove it.
Okay, I get it.
So you need to give him the bash, job.
Also,
This is the idea.
we need to, after we start to run container, and then we need to use access.
Execute, not run. Run, it's to execute new process each time. If you want to work with your old containers, each time use execute. And don't forget the Docker stop and start. This is why it's important to check always the state with Docker PS and Docker PS minus A to see the state, if it's working or not. Get it? All right. All right. Anyone need help? Or it's perfect for everyone? All right. So here, I want to show you the next step, which is now you know how to run something inside the container, outside the container, right? This is the solution. Again, it's the same thing. I think everyone will get it. So now, very important two parameters, which is the minus V, volume, and port. Why it's important? Because in reality, no one gonna create a container and do some Python scripts or create some bash scripts onto the container. No one gonna do this. You're gonna work on your own local machine, right? So for that, you need to create a bridge, a volume bridge between your local machine and the container. And for that, we need this command, which is the minus V, to create a bridge. For example, working directory, and I create a folder, call it my code here, inside the container, and it's gonna create a bridge. Let's see how it's gonna do it. If I'm gonna take, for example, this command, so it's similar and exactly the same thing as you were doing, right? I'm using the Miniconda image, but this time I'm adding these parameters, which is the working directory on my local machine. I'm creating a bridge and a volume and the folder that I called my code. So imagine I'm here. I'm working into my folder, which is the Introduction to AI workshop series. If I look at this folder, okay, I'm having the whole materials of our workshop downloaded from my GitHub, for example. So you have your own local scripts, and I run this command. All right, I'm inside the container. We are used to it, right? Now you have the idea. If you check this time a list, you're gonna see that I'm having a new folder, which is my code. And this is inside the container. So if I'm going to my code this time, I'm gonna find my local scripts. And this is amazing, because now I can go to Introduction to Deep Learning, for example, and find all my Jupyter notebooks or Python scripts or wherever you want, which means that now you know how to, for example, if you are working on some projects and you find an interesting library that you want to test. The problem, again, it's not gonna be able to install it in your own machine. It's going to create some conflicts with the libraries. You want to avoid this. How you do it? Take this image, download it from Docker Hub using this library. It's going to be there using the environment, isolated. And you run a container using this image with the library that you want to use. And you put a breach between your local machine and this. And you're going to test your Python scripts using this library. You didn't like it? All right. You delete the container, you delete the image. And that's all. Nothing happens, which is amazing, right? You can avoid all the different conflicts. Now you can get and go a step further. I'm going to exit this. So using volume, you can add another parameters, which is the port, which means you can publish the ports from the container into your local machine. Again, I'm working on a data scientist. I'm working on some data science environment. So for that, I'm going to use this image. We have already seen this in Docker Hub. Jupyter Data Science Notebooks. I like it. So for that, you're going to use Docker run. We have seen this, -IT to be inside the container. And then you can add and combine, I'm going to give him a name, the volume, which is a breach between your local machine and the container. And you're going to publish some ports. Here, 88, 88. I'm going to give him 10,000. Why? Let's see an example. If I'm going to run this command here, turns out that it's going to give me a Jupyter notebook already ready. For that, I'm going to copy this link of my Jupyter notebooks. But these Jupyter notebooks is from the Docker image, which is called Data Science, which contains all the libraries of the data science. So if I'm going to run this, you're going to see it's not going to work. It's localhost 8080. Why? Because I'm using 8080, but we have seen that we created and published the ports in 10,000 in our local machine. So 8080, it's working on the container, but you want to run it in our local machine. So for that, I'm going to use 10,000. And now I'm having your Jupyter notebooks using the data science environment, you see? This is the Docker image of the data science. It contains everything, the Julia, R, Python, and I didn't install anything, just download the image, which is the environment in our case. And again, I added the -v to create a breach of the volume. So if I go to the folder which is inside the container, which is my code, I'm going to find my Python scripts. And here I can work using this Docker image, this environment, this data science environment, which contains everything, every library, imports, I don't know, NumPy, for example. It's going to work. You see, I'm having all the libraries of the data science, which is amazing. Now you can create it. All right, tell me. Yeah. Exactly. Exactly. This is the idea of the breach. I'm working on my local machine. Here, for example, you see, if I do create new folder and call it, I don't know, test, for example. Right? I call it test, which contains import NumPy. So you created the new job. If I go here and look at its which working directory, it's the work training. Okay, just to get the path, I'm gonna go into my local machine here. And if I go here, I'm gonna find this file test. You see, he's here. So you created the breach. To internet? No, you don't need to internet. It's running locally. the Docker image is running locally, so the environment is running locally. So if I'm using a machine learning model that I want to train, he's using my local machine resources. You see? You're going to need the internet, of course, to pull the image, to download the environment that you want to use. You see? So here it's amazing. So you created an isolated environment that you can test on it, different libraries, and it's not going to impact your local machine, which is amazing. $10,000 is just to create and publish the ports of 88 running on container. Because Jupyter Notebooks, when you're going to run it, by default, it's going to give you 88.8. And you're going to publish this into your local machine to create a passerelle or tunnel, we call this, to 10,000. I could choose 8080. I could have done it. We can choose other ports as you wish. And it's going to be running locally this time. Amazing, right? Now, you have an isolated environment that you can test and do a lot of stuff on it. Again, I didn't mention this, but you can do everything using Docker Desktop. You can see here, you have your containers that you have been working on, and you can start and stop them. For example, here, I'm going to stop this one. And you can start it again. This is the new one, which is Jupyter container, the one that I already created here. And you can give it, it's going to give you the local host and the ports. So you see, you can do everything using the Docker Desktop. And if I click here, it's going to give me here. But again, you need the token. So you can do everything using Docker Desktop. You have the containers, the images that you downloaded, so you can stop them, running them, deleting them. You can do everything. Now, you can go step further, and you can see that now we can do this kind of stuff, which is amazing. Because just by using a VNC, which is forwarding, I can do this kind of stuff. Now I'm going to quit this container here. I'm going to use this Docker image, which is going to allow me to have access to Ubuntu, but this time, localhost, put my now you can have an Ubuntu with graphical user interface running on a browser with some application, as you can see, Slack, VS Code, obvious, which is amazing, right? And you can do a lot of stuff and test a lot of stuff on it. Amazing. It's running on my own local machine here on the browser. And you can create a bridge, and you have the whole systems running in a browser. Execute, you see, everything. And I'm running Windows, as you can see. This is the kind of stuff that you can do and test, which is amazing. It's gonna allows you to create a lot of possibilities. An example, another example is to create, if you are working with MATLAB, it turns out that it has a container and Docker image, which is amazing, because now, if you have a license for it, you go here. At cost, we have a license, so just put your ID. And now it's starting MATLAB as Docker image into the browser. And you can work in a browser using MATLAB, which is amazing, because imagine you are using different, I don't know, operating system or a different PC or micro. You're not at home or you're not at your office. You need to use different computer. Here, just by downloading the Docker image, a running container, you have your own MATLAB running in a browser. Amazing, right? This is why it's a must nowadays to know how to use Docker. There are small last steps that I want to show you. Now we are using what we call already pre-built images, right? Let me just exit this. But in reality, you want to create your own application, right? Your own environment, which means your own images. For that, we have what we call Docker file. And this is how it looks. Imagine you want to build your own image with your own specific libraries. For that, again, here you can create a file called Docker file, as you can see here. Let me just do this. Docker file. All right, you create something like this, Docker file, and you put something like this one, as you can see. Imagine you don't want to create from the beginning. What you do, just from the image that you like, the Jupyter Notebook data science, for example, or Miniconda, or just Python, or just Ubuntu, you just want Ubuntu to install something. You start from this image, and then create a working directory. You call it app, for example, here, and install each library that you want. I want a Python 3.9, 3.12, as you wish. JupyterLab, NumPy, Panda, Matplotlib. You can do whatever you want. And then you're going to expose the 8080 if you want to work. For example, this image, I want to run a JupyterLab with my own libraries that I want to work with it, which is NumPy, Panda, and Matplotlib. These are the libraries that I want to work on it. So I need to expose this port, because I know that JupyterLab is running on this port, and can run a command like this one. And here, just to build this image, you just need to do Docker, as you can see here, Docker build. And you give him a name, Docker build -t, to tag the image, and I call it my Miniconda JupyterLab, and I created a custom environment specific to me. And you put the dot to include all the files. I already created here. So now I have a new Docker image. If I look at the Docker images, you can see that it's here. It's a new image. My Miniconda JupyterLab with my own libraries. And now I can run an instance using it, right? And this time you just need to do Docker run. Here we put in general -rm to means that at the end of what you have done, when I exited the container, when I finished my job, it's going to remove by default the container. I don't need to go look for it and do Docker rm to remove the container. So I just run an instance, do my job, quit, and it's going to be removed, which is amazing for creating a lot of process and running a lot of Python scripts using different Docker images. So here, if I'm going to do the Docker run, let me just copy this command. You see, I published the port, as you can see, to 10,000 here. Now, if I'm going to do this, and again, it's running localhost, so this is why it's like this. Now it's running in JupyterLab, but this time with my custom libraries. And again, you can create a bridge between your local file using -v, but this is how you can create your own images, which is amazing. So the next step that you created this, you can push it to Docker Hub to make it either public or private. If you make it public, you can then, I'm going to tell you, all right, don't install everything and just pull the image and you're gonna have the environment, which is amazing, right? No one gonna be like in trouble again. It's gonna work everywhere. And again, why it's a good idea to do this? Because imagine you are working on a project, you finalize it, you created an app, and everything is working, but you don't want to share your source code and all your scripts. You want to share only the application. Now with this kind of stuff, you can Dockerize your application like this. This is the last thing that I want to show you. So just remove this. It's running here. You can create, you remember the heart disease app? I want to share it with you. How am I going to do it? Create a new Docker file. For that, I don't need Miniconda, it's heavy. It's like 1 gigabyte. Just, I need an image of Python 3.9. This is all what I want. Then I'm going to create my working directory, put the scripts that need to be executed into this harddisease.py, then run some dependencies, and put all the libraries that I need to run the application. Streamlit, Panda, Matplotlib, scikit-learn, in order to run the machine learning model. Then expose the port where the application Streamlit is gonna run, which is 8501. And then you can create something like this and run directly the application. And here you Dockerized your application, which means I Dockerize it, I push it to a Docker Hub, and if you go, for example, now to my repository, which is Abdelghafour 1, you can find this image, because you can share it, of course, or put it like private. Here I'm putting it as public. So you can find this image, which is Abdelghafour, heart disease app, and I put you a command that just need to run it. Again, if you run a Docker run using an image that it's not downloaded already in your local machine, it's going to do the job of pulling it. You don't need to do Docker pull and then Docker run. If you don't have the image, you do Docker run, you're going to understand. It's not on your local machine. You're going to check the Docker Hub, and you're going to download it. So here, you can go here to Docker Hub, look for my repository, for example, Abdelghafour. You're going to find this heart disease app. And you can run this here. And it's going to give you the local host. And it's going to run. I shared with you my application without any conflict, without telling you need to install Streamlit with this kind of libraries, with this typing, this version, and this. No, just Dockerize the thing, share it, and it's running on your own local machine. And now you can use it, for example, here. Let me just look at for the file, and it's running, you see? Locally, as a container, which is amazing, because now the next step is, if you are working in the same network, you can see here, it's running, it's loading, and it's doing everything locally. We don't, without any installing anything, just by doing Docker run. Now, imagine you want to share it. But again, you can share it as an image. That way, you need the guy to pull and install Docker Desktop to make it run. But imagine you want to run it in your own machine, just you want to do a demo for a client. You keep it running in your own local machine and give him the access just by giving him, not it's running localhost, giving him the IP address of your local machine. If I'm going to give you the IP address of my local machine here, you're going to be able to access this app. And you're going to do the stuff, and it's running on my own machine, which is amazing to share something to clients. You need to do the expose the host here, as I already did. As you can see, 000, that you can access to it. But this is the kind of stuff that you can do, which is, I find, yeah. Yeah. Yeah, imagine I want to add a new library for this. You need to build. I need here, again, Seaborn. I want to add this library to my Docker file. Just build. Just do the build again of the image. And it's going to contain the new libraries. The tag, just to give name to the Docker images. Yeah, exactly, yeah. With different version. Again, which is good is that you can do this kind of stuff. Use the same name of the Docker image, but you add, I don't know how to, and you give it version 1, or version 2, or Seaborn. And now you're gonna have this kind of images. Let me just show you. If you wanna use the same image, but with different version. You're gonna have these same things. I'm having the same Docker image here that I'm using, but I have different tag for it. One, the latest, and one with, I know that in this Docker image I have Streamlit. So I put tag, as I will show you, using Streamlit. And that's it. That's our for today. I hope you enjoyed and learned something. And this is the end of the AI workshops. I hope that I showed you an overview of all the domain data science fields. And thank you. Thank you, everyone. Thanks.